Hello, the topic for this video is section formula. So we'll be studying section formula under coordinate geometry. What is section formula basically? It's actually a formula which enables us to find out the coordinates of a point which divides a given line segment into given sections. You have done it in 3D geometry. Suppose we have any 2 points P and Q. So there are infinitely many points on this line segment, and each point divides this PQ in some specific ratio. So section formula is basically, if you have been given that ratio, then you have to find out the coordinates of the point. So if you have been given the ratio in which this line segment divides this point divides this line segment, then you have to find out its coordinates. So it enables us to find out the coordinates of a point which divides a given line segment in the given ratio. Okay, I said given line segment and given ratio, that means the ratio would be given and the line segment would be given. Line segment would be given means actually the coordinates of the points which makes the line would be given. So you did this in class 10 in 2-dimensional. We'll be carrying forward the same concept in 3-dimensional geometry. Here I have made a 3-dimensional plane where 3 lines are perpendicular to each other. Okay, so just look at this picture from a perspective of a 3D system. Okay, so you can see this x and y plane projecting outwards. This y is projecting outwards from the board. Okay, and x and z you can consider them on the board only. So here I have located 2 points P and Q, and both the points are in the first octant. They are in the first octant. Here you can see the images of point P in the x, y plane, P and Q. Let these images will be this. Okay. So before I move ahead with the topic, just refresh some visuals here. See, this is an xy plane. So xy plane is something projecting outwards. No? So every line parallel to z axis is gonna be perpendicular to xy plane. See, this is your xy plane and z is perpendicular to xy plane. Z is perpendicular to x direction, z is perpendicular to y direction. That means z is perpendicular to xy plane. You can visualize the plane like this. It's actually projecting outwards. Okay? And if z is perpendicular to every point on xy plane, every line on xy plane, so that means this will be perpendicular to this line will also be, because this is parallel to this is parallel to this. Both of them are gonna be perpendicular to any line on this plane. I'm just focusing here. Suppose this is a line on xy plane. There are infinitely many lines in a plane. Okay, suppose these all are the lines. Okay, in this plane. So if we take this line, then this QQ dash will be perpendicular to this also. This is gonna be perpendicular to this. If we take this line, then this line is again gonna be perpendicular to this. And this is perpendicular to this also. Because all of these lines are actually on this. So this line is perpendicular to all the lines because it's perpendicular to this plane. Okay. So now we'll move ahead with the concept. This is Q dash. So here we have 2 points P and Q whose coordinates are this and this. We have to, where do we have to reach? Let's join PQ. Suppose this is a point, you can say R, which divides this line segment in the ratio m ratio n. Okay, m ratio n, x ratio y, whatever, let's take it, m ratio n. So it's dividing this line segment into m ratio n. So it's a unique point now. There's only one and only one point which can divide PQ in m ratio n. There can't be two points. So if it is fixed, if it is a unique point, we should be able to find out the coordinates of this. That's actually it's actually how it should go. If something is fixed, we should be able to find out all its positions of all such points with the help of the given things. So here we have to find out the coordinates of this point. Now, coordinate of this point are actually the coordinate of so xy coordinates. It's in the first octant, so it's gonna have 3 coordinates. XY coordinate of this point are actually equals to XY coordinate of this point. No? Because R and R dash just differ in their Z coordinate. Z coordinate of this is 0 because it is on the XY plane, and Z coordinate of this will have some value. The X and Y coordinates are gonna be same. Just like of this also here, this is x1, y1, z1. How do we reach this point? See, if we have to reach this point, we have to travel some distance in the x-axis. No? Somewhat like this. Then we have to travel some distance along the y, and then we have to take the height. No? X, y, and then your height. Then we reach here. How to reach Q? First we have to go, I would say this, then this, and then upwards. So this is basically x distance, then y distance. Why am I drawing it like this, not this? Because it's 3D system. Just see, it should be parallel to this. Okay, and this is basically this is right angle. You may perceive this as 90 degree, but no, this is the 90 degree direction. This is not the 90 degree direction. Okay. So to reach here, we have to follow this pattern, and here also. Okay. So the coordinates of this to reach this point also, how we have to move? Just like this only. Okay, we'll reach it. Traveling this will reach here, and then from there we have to reach here. No? And then we have to gain this height. So xy coordinate of this and the xy coordinate of these are gonna be same. Xy coordinate of this and this are same, this and this are same. So you can actually say that this is x1, y1. You can say 0 also, or let's not write it because this is a point in xy plane. Whenever you will be dealing with octants, you will be asked to asked to find out the coordinates of point P in this space, and the point is here, then you will write 0, but it actually doesn't matter here. And here the coordinates are x2 and y2. Okay. Now, what are the coordinates of this? We have to find out its coordinate. No? Because its coordinate are related to its coordinate. No? How come they are related? I'll explain that. First, let's find out its coordinate. Okay? Let's join these two. Okay? Now, How to find out coordinates of this point? R dash. See, the reflection of this line here, it's gonna be this. No? Why am I drawing it like this? See, this point P is somewhere here, and or you can say this point Q is this and point P is this. They are somewhat like this. Got it? So this is also projecting outwards and this is also projecting outwards. In fact, this full plane PQ, Q dash, P dash is projecting outwards of the blackboard. So this is 90 degree as I said earlier, and this is also 90 degree. No? Let us focus here. This R point divides PQ in the ratio M ratio N. And this line is parallel to this because both are the heights. So as per the basic proportionality theorem, a line drawn parallel to any side of a triangle divides the other two sides in the same ratio. So as this is parallel to this, so this will divide these both lines in the same ratio. So as the ratio here is M ratio N, so here also the ratio is gonna be M ratio N. And so is here, because it's a rectangular frame. No, this is 90 degree. Okay, this is 90 degree. This is 90 degree. So they all are 90. So it's a rectangular frame. So this is also M ratio, and so is this. Sorry. So now, can we find out the coordinates of R dash? Yes, we can, because this is XY plane and we know the section formula in the inner plane, no? So X and Y coordinates of R dash can be found out. Okay, R dash, what is the X coordinate? You know, the formula is N into X2, N into X1, M into X2, Mx2, Nx1 over M plus N. Similarly, Y coordinate is My2 plus Ny1 over M plus N. So we got the X and Y coordinate of this point. So X and Y coordinate of this point is also the same, and of this also the same. No? Just like that, just visualize this as a plane. No? So we got the X and Y coordinate of this. Let's write it with something else. We got the X and Y coordinates of this in terms of this and this. We have to find out Z coordinate of this in terms of Z1 and Z2. For this we need to draw a picture again. See, let's focus here only. This is your Z. I'm just enlarging this frame here. Okay, this is Z. Then you have your point P, and you also have your point Q. Let's take it here. Okay, and we have to find out the Z coordinate of this point R. No? What else do we know? We know that this point R divides PQ in the ratio M ratio N. No? Now, if we know the Z coordinate of this is actually this height from the origin. Okay, that means this is your Z1 and this is your Z2 and this is your Z coordinate, and we have to find out what height is this. No? So, see, I'm doing something here. I drew a line parallel to z axis from here. Now we have a right angle triangle. Again by basic proportionality theorem. This line is parallel to this. So a line drawn parallel to any side of a triangle divides the other two sides in the same ratio. So as this line is dividing PQ in the ratio M/N, so it will also divide this line, it's dividing it from here. It will divide this side of the triangle in the ratio M/N. Now that means this is also M/N. Now if we have to find out the z coordinate of this point, that is actually associated with this. No? This is associated with this and this is associated with this. So here this divides it into M/N. This point is, this is Z1. Let's write it to something else. This height is Z1 and this height is Z2. And this divides it in the ratio M/N. Now, so again we can now, because I am just working on one plane, what am I doing actually? What did I enlarge actually? Okay, I have taken this plane, a plane containing z axis, a plane containing P and Q. See, infinitely many planes can pass through this, many, no? All around. Okay, one is this. Let us draw it that side. I basically drew z-axis and there are 2 points, P and Q. No? There are 2 points, P and Q. So what did I do from these 2 points? I dropped perpendicular over it. Okay? So there are 2 points, P and Q. I basically dropped perpendicular over it. Now what is this? Aren't we getting a plane? So this is a plane. This is a plane projecting outwards from z-axis. Okay? So if it is a plane, so we can use all the properties of a plane. So that's what I am doing here. It's a plane where R divides PQ in the M/N, and so by Thales theorem this got divided into M/N, and so is this. Okay? So as this point divides this line segment into M/N, so and as it is a plane, so we can use section formula here to find out the coordinates of this point. No? So coordinates of this point, suppose this is Z, this is gonna be MZ2 NZ1. MZ2 plus MZ1 over M plus N. No? Now this is the Z coordinate of this point, and so is the Z coordinate of this point will be same as they lie in the same plane. No? So that in that way we got all the coordinates of R. So the coordinates of R are mx2 plus mx1 over m plus n, my2 plus my1 over m plus n, and mz2 plus mz1 over m plus n. So we are able to find out the coordinates of a point R which divides a given line segment in the ratio M/N, and its x, y, z coordinates are respectively this, and this. So basically it is somewhat similar to the formula which we obtained in the 2D system, and so was the derivation here. Now you can use this formula to find out, to sort out your sums basically. Okay, thank you.